The rainbow is one of nature's most impressive masterpieces. It is a demonstration of the dispersion of light and is evidence of the spectrum wavelengths that make up white light. The three necessary components for seeing a rainbow is bright sunlight, suspended droplets of water, and proper angle setting. In order for a rainbow to be viewed, your back must face the sun at a 40 to 42 degree angle above the ground in an area with light mist. But how do these droplets of water exactly disperse and reflect light? In order to fully understand the physics behind the rainbow, we must understand what light is, the concepts of refraction, internal reflection, and dispersion of light. So what exactly is light? The term light describes the visible spectrum, which is a range of wavelengths that together form the visible part of the electromagnetic spectrum. The visible part of the electromagnetic spectrum ranges from 380 to 750 nanometers. Each wavelength corresponds to the light of one color, ranging from wavelengths appearing violet, blue, green, yellow, orange, and red, and all the colors in between. Roughly equal amounts of each wavelength make up white light. Reflection is a change in direction of a wave at the boundary between two different mediums so that the wave returns into the medium from which it originated. The law of reflection states that the incoming sunlight, also known as the incident ray, as well as a reflected ray and the normal, all lie on the same plane. The normal being a line that is perpendicular to the medium in which a light ray is striking, separating the incident and reflected ray into two equal angles. Refraction is the change in direction of propagation of a wave due to the change in its transmission in the medium. The law of refraction is a formula used to describe the relationship between angles of incidence and refraction when referring to light or other waves passing through a boundary between two different mediums. The separation of visible light into different colors is known as dispersion. Upon passage through a prism, white light is separated into its component colors red, orange, yellow, green, blue, and violet. The introduction of water droplets into the atmosphere causes them to act as a refractor of light. The water acts as a medium with a different optical density than the surrounding air. Light waves refract when they cross over the boundary from one medium to another. The water droplet causes a deviation in the path of light as it enters and exits the drop. The light decreases in speed as it enters a water droplet, which causes a bending of the path of light. As the light exits the drop, light speeds up and bends once again. Since the boundaries for the droplet are not parallel to each other, double refraction results in a distinct separation of sunlight into its component colors. There are multiple pathways by which the original ray can pass through a droplet and subsequently angle towards the ground. Some are dependent upon which part of the droplet the ray contacts. Others are dependent upon the location of the sun in the sky and trajectory of incoming waves towards the droplet. When observed from ground level, rainbows appear as arcs, but when observed from an airplane, rainbows appear as complete circles. People on the ground only see the top half of the circle since the bottom half is prevented by the presence of the ground and suspended water droplets above ground. Every droplet within the rainbow arc is refracting and dispersing the entire visible light spectrum. Red is seen at the top and outer perimeter of the rainbow, while blue light is seen on the bottom since red light is refracted out of the droplets of water at a steeper angle towards the ground than blue light. So when an observer sights a steeper angle with respect to the ground, droplets of water within this line of sight are refracting the red light to the observer's eye. The blue light from the same droplets is directed at a less steep angle and is directed along a trajectory that passes over the observer's head. However, this would mean that we are seeing an upside-down rainbow, but why is this not the case? Since every droplet is refracting these visible rays of light, droplets at less steep angles direct red light towards the observer's feet, while blue light is directed to their eye. Rainbows are a combination of multiple refractions of light passing through the multiple droplets at various angles in the atmosphere. Now that you know the physics behind the rainbow, hopefully you can appreciate its beauty more.
Created using Powtoon.